Difference between PDCA and DMAIC. Application of PDCA and DMAIC in problem solving. Hello and welcome. Today, we're going to dive into two powerful problem-solving methodologies, PDCA and DMAIC. These acronyms may sound complicated, but don't worry, we'll break them down together. First, let's start with the PDCA cycle. PDCA stands for Plan, Do, Check, Act. It's a method for executing continuous improvements, and it was first introduced by Dr. Deming, a quality control expert. In the plan phase, this is where you identify the problem, set your goals, and develop a strategy to achieve them. Think about the resources that you need, the timeline, and any obstacles. Remember, the more detailed and comprehensive your plan, the smoother the process will be down the line. As you plan, consider the following questions. What is the core problem that we need to solve? Is this the right problem to work on? What information do we need to fully understand the problem and its root cause? Now that you have your plan in place, it's time to move on to the do phase. This is where you put your strategy into action. Execute the tasks outlined in your plan, and make sure to monitor your progress closely. Keeping track of your progress can help you stay on course and make necessary adjustments along the way. Once you've completed the tasks in the do phase, it's time to enter the check stage. This is where you evaluate the results on your actions and compare them to your original goals. Analyze the data that you collected during the do phase to determine what worked well and what didn't. Remember to be objective and critical during this stage. It's important to recognize both your successes and your failures so you can learn from them. Now, let's move to DMAIC. DMAIC stands for Define, Measure, Analyze, Improve, and Control. It's a structured problem-solving method often used in Six Sigma projects to improve an existing process. In Define phase, select the area of improvement and define the specific improvement project. In Measure phase, assemble measurable data about process performance and develop a quantitative problem statement. Measure the current level of performance and identify KPIV and KPOV. In Analyze phase, analyze collected data to determine the significant contributors, causes, of the problem. In Improve phase, we improve process by selecting the right solutions to solve the problem. Team might come out with many possible solutions, all of which would provide some improvement for the process. In Control phase, we control the improved process to sustain the gains. For example, implement Statistical Process Control, SPC, for monitoring process behavior and implement mistake proofing or Poka-yoke to make errors impossible or immediately detectable. Both PDCA and DMAIC are iterative, meaning you repeat the process until you achieve the desired improvement. However, they differ in their approach. PDCA is simpler and more flexible. It's perfect for smaller, less complex problems, where the cause is already suspected. It's also great for making continual improvements in processes. DMAIC, on the other hand, is more structured and data-driven. It's better suited to larger, complex problems where the cause isn't known. It's typically used in Six Sigma projects to reduce process variation and improve quality. In terms of application, PDCA is frequently used in manufacturing, healthcare, and education to continually improve processes. It's about making small, incremental changes that add up to significant improvements over time. DMAIC is often applied in industries like finance, marketing, and IT, where reducing process variation is critical. With its data-driven approach, DMAIC is great for finding the root cause of complex problems and ensuring they don't reoccur. So, in a nutshell, both PDCA and DMAIC are powerful problem-solving tools. Choose PDCA for simpler problems and continuous improvements, and DMAIC for more complex issues where data analysis is key. Thank you for joining us today. We hope you found this comparison of PDCA and DMAIC valuable. Remember, the key to effective problem solving is choosing the right tool for the job. Until next time.